X-ray and Industry 4.0. We are on the verge of a technological revolution that will fundamentally alter the way we live, work, and relate to one another. In its scale, scope, and complexity, the transformation will be unlike anything we've experienced before. The first industrial revolution used water and steam power to mechanize production. The second used electric power to create mass production. The third used electronics and IT to automate production. Now, a fourth industrial revolution is building on the third, the digital revolution that has been occurring since the middle of the last century. It is characterized by a fusion of technologies that is blurring the lines between the physical and digital. There are three reasons why today's technology changes represent not just an extension of the third industrial revolution, but rather the arrival of a fourth and distinct one: velocity, scope, and systems impact. The speed of current breakthroughs has no historical precedent. When compared with previous industrial revolutions, the fourth is evolving at an exponential rate rather than a linear one. Moreover, it is disrupting almost every industry in every country. And the breadth and depth of these changes herald the transformation of entire systems of production, management, and governance. Within the manufacturing world, the possibility of thousands of devices connected with unprecedented processing power, storage capacity, sensors, and software intelligence are unlimited. In the industrial and manufacturing sectors, industrial Internet of Things is not a new concept. Our industries have long relied on proprietary computer systems and sensors to monitor equipment and operations. But as we enter Industry 4.0, these systems and sensors are becoming more and more interconnected and leveraging machine learning to automate industrial processes. Traditionally, the data gathered from industrial sensors is pushed from proprietary PLCs into SCADA systems for analysis with a lot of layers in between. Typically, OEMs wouldn't support any sort of integration to a SCADA system, but cloud industrial IoT is opening all of this up and reducing the amount of layers from the data capture to actionable intelligence. Traditionally, the top layer comprises of the management systems. Servers and software communicate between this layer and the factory floor. This informs the process as to what needs to be manufactured based on customer orders. This layer coordinates all front-end and back-end factory logistics to fill these orders and enables automated monitoring without human intervention. The middle layer is the control layer. PLCs interact with SCADA systems and receive instructions on what to manufacture and how to do so. This initiates various processes and operations on the equipment, executes instructions, and monitors the condition of those processes. The bottom of the industrial automation pyramid is the factory floor. This is where equipment lives. Communication protocols link peripheral devices including sensors, barcode readers, etc. to the manufacturing machines. OEMs have usually digitized their equipment, but often the data and information remains siloed. Now we're moving towards an interoperable world where this data transmission is electric and instantaneous. Equipment like our X-ray inspection systems should be able to monitor and broadcast data throughout the pyramid. This takes us to our next generation of inspection equipment. Inspection equipment can serve as a barometer for production line health. Often, the variations only visible to the inspection equipment can anticipate a problem in the upstream process, such as a failing filler valve, worsening raw material quality, or weak glass jars that can break later during the cooking process. Our equipment can observe these trends and communicate those into your plant control software and make the equipment proactive rather than reactive. So how do we do this at Peco InspX? Well, we've got our shield system architecture that monitors and communicates data in real time. This data can reside in the cloud or be on premises at your local data servers. Our analytics software distills this data into actionable insight, and this information can then be broadcast into your plant monitoring software with standard communication protocols like TCP/IP or Modbus or Ethernet IP. With this interoperable architecture and our intimate view into the production process, there are some interesting things we can do. Typically, our inspection equipment runs unattended. You shouldn't need to wait for an operator to walk by and notice a problem. Our equipment learns from normal production rates and form material rates and can notify you if there's been a deviation. This data could then potentially be used to evaluate the quality of a raw material supplier, for example. Another example relates to your QA challenge program. Most customers have an hourly check where they ensure that the system is performing at the required quality specification. Let's say you're looking to detect a certain size metal contaminant and a certain size glass contaminant. But as you have plant turnover, you could have a new operator that doesn't realize there's a problem. So instead, let our software ensure full compliance, traceability, and communication of your QA program. You could automatically get a message if any machine has missed a challenge sample, or if any operator has changed the inspection threshold or sensitivity parameter that has detuned it such to the point where it's now failing to detect your contaminant. Let's look at some use cases of this new technology. Let's say a customer finds a metal shaving in their can of soup. Wouldn't it be great to match a shipped package to its X-ray image to determine what was in it when it left the factory? Well, we've got a coding module that allows us to link each digital X-ray image and inspection results to every single package. Our system would print a unique 14-character code on the container to indicate the results and which file name the data is stored under. All the good and reject containers will be marked for full package traceability into the future. What about defect detection in raw materials? Do some bean suppliers have more stones in the beans, and which ones are they? We could estimate the total number of stones per ton in inspected product and use that data to feed back to your plant monitoring software in real time. Here you can see on the screen our Kepware interface as one of the methodologies we would use to transmit the data. How about for more immediate emergency action? Let's say several large metal foreign objects are detected in a row. Could you alert management? Our equipment can be configured to notify you on specific inspection trends. So for example, if several consecutive containers have a large metal fragment in them, it's usually a good sign that something has happened upstream, and we can send an alert to the responsible party and get critical problems real-time attention. What happens if you have a lot of turnover in your quality group and aren't always able to reliably ensure the equipment is set up correctly and consistently rejecting what it needs to? In that case, we've got several ways we can help manage your quality process. We can tell if the X-ray machine has successfully passed each challenge event. We can notify your operator to administer the challenge within a short window at the top of every hour. And if any challenge fails, we can automatically execute some line control or notify the appropriate personnel. Then all the challenge testing is recorded into a log to provide an auditable trail of compliance with your quality procedures. Employees can sign in and out of our equipment scanning their existing ID badge on our built-in RFID reader, so you have a full record of interaction with the equipment. In a manufacturing-driven economy, Industry 4.0 is key for sustainability and competitiveness. This requires a transition from our current digital equipment to next-generation intelligent equipment. In order to accomplish this task, OEMs must focus on providing full digitization of their processes and controls, comprehensive instrumentation of their equipment, an intelligence layer for interpreting this data, and support for communications up and down the line. Once we do that, we can expect significant advances. With that said, I'd like to thank you all for your attention and open up the live chat for any questions that you may have.
All right. I hope you guys found that somewhat enlightening. There's been a lot of discussion about Industry 4.0, but it's not always clear what people are referring to when we talk about that. So Peco, and we thought it would be a good idea to put out some content to start talking about the implications for our particular industries. So I think we've got a couple of questions.
If we have Kepware in our facility, do you support communications to that?
Yeah, so We have a few different communication modules that we can enable on the equipment to communicate out to your plant level operating software. Kepware is an example of one that we do have support for. We have a couple of published specifications on which registers and which functions are accessible for each of the different protocols. So if you've got a particular flavor that you use in your facility, we can send you our details on that, or work on developing something if we don't have it.
Regarding track and trace, can you not only mark the rejected packages, but could you also mark every package?
Yeah, so that's a great question. I think the expectations of not just end user consumers, but also retailers who share some of the risk in potential litigation is to have better control up and down the production process of foreign material risk. And so when we do a full container inspection and certify that a product is free of foreign objects, and it still gets out in the hands of some customer who says they found something, we really would love to tie that particular package back to the X-ray image or whatever inspection we took at that time that it was in the facility. And we can do that not just on the rejected packages, but also on the good packages. And that kind of gives you an end-to-end traceability for contaminant performance and verification.
This industry 4.0 is a complicated opportunity, I guess, for many companies to figure out how to deal with. Would you say that conversations you're having on this, how in depth do they go, and what's the best path forward if you want to have a comprehensive discussion on it?
So, in our experience, we've been developing this technology for the last 4 years. And our customers, the food and beverage manufacturers out in the world, are starting to have more and more discussions with us about this. It's a topic that only recently is getting more attention amongst facilities. I think the expectation of devices being connected now is growing. You go to Best Buy and purchase a dishwasher or a refrigerator. They're all Wi-Fi enabled, and they've got video chat on them and all these other seemingly ridiculous functions. That's kind of underscoring what we're seeing in our industry. The expectations of being able to get information seamlessly off of the equipment into the plant ERP and management software is a baseline expectation. And we haven't seen the adoption rates that we expected. I'd say we're still a little bit ahead of the curve there, but I very much expect this to be an absolute requirement moving forward.
And from what we've seen, the questions have been very different from just about any customer that we've dealt with. So please, after this, whether chat or give us a call, let's work on it. Any of the questions that you have, please get back with us.
All right. With that, I think we'll end it here.
Thank you for your time.